All right, good morning, good afternoon, good evening, depending on the time you are listening to me. My name is Mr. Wongu Eric Chemeka, and we are talking on physics, particularly on the topic magnetic field. First, before we commence, I will show you the content we are working with. First, we are going to consider the concept of magnetic field, and then we'll delve into magnetic field pattern. We will see the diagram of the bar magnet in field pattern. We'll also talk about the diagram of the right-hand rule. And then lastly, the Earth's magnetic field. Then we'll conclude before we share the project work, which the students have to perform. All right, concept of magnetic field. Field of an object is the region around the object which the influence of the object is felt. Therefore, magnetic field is the region around a magnet which the influence or the magnetic force of the magnet is felt. We can use a metal or compass to detect the field of a magnet. When brought close to a magnet, it is a vector quantity and has its line of force imaginary. Hence, it cannot be seen physically. All right, looking at a magnet, if you bring a metal close to a magnet, before touching the magnet with the metal, you can see that there is a force that drags the metal to the magnet. The point at which the metal will get to and feels the dragging is what we call the magnetic field. That is the region at which the force of the magnet is felt. Let's call it the terrain or the jurisdiction of the magnet. And this magnetic field is a force field. And a force field is a kind of force where there is no contact with the object, in quote. And then it's a vector quantity because it has magnitude and direction. It takes a metal that is coming close to it to a direction, to itself particularly. All right, the lines of force of this magnet is imaginary, which shows that it cannot be seen physically. But when you practicalize it in the lab, you will feel that there is a force possessed by this magnet. All right, we'll go to the next one, the magnetic field pattern. We can conveniently observe this using ion filings on bar magnet in the laboratory. It is simply the flow of the magnetic force of a magnet. It shows this magnetic field pattern, just like the English statement is just the pattern at which the field of the magnet is arranged. The line, the pattern, the steps it takes in doing its work, that is the magnetic force. So that is just the simple understanding this gives us. Below shows the magnetic field pattern of a bar magnet. In the next slide, we're going to be showing you the field pattern of a bar magnet. And a bar magnet is a magnet whose poles are known. We have the north and the south pole of the magnet. We can see that the magnetic force moves from the north pole and into the south pole. This is different from a straight current carrying conductor or wire whose magnetic field is in concentric circle. If you have a wire that is carrying current, that is what we call a conductor here. If you have a wire which is connected to an AC or a DC source that has current passing through it, when you bring ion filings to it, which will experiment in the laboratory, you will see that the line of force of this magnet, the magnet produced by this conductor is concentric. It's like in a circle form, which its own line of force is what? Different. The direction of the force is dependent on the flow of current through the wire. It can also be traced using the right-hand rule. If the wire is grasped in such a way that the thumb points in the direction of the current, the direction of the other fingers shows the direction of the magnetic force. We can see that in the next two slides, which I will explain in detail. All right, the next slide, this is showing us the line of force of a bar magnet. You can see a bar magnet. I told you that the bar magnet is a magnet whose poles are known. We have the north and the south pole. You can see that the magnetic force is flowing from the north to into the south pole. The south pole is the receiver, while the north pole is the donor. When it gives out the force flows from the north to the south. When this is performed in the lab using ion filings, you will see more detailed explanation. All right, the next slide is showing us the right-hand rule. I told you that in the previous slide that the right-hand rule, when you are holding, look at this, this hand is holding is the wire. If you hold the wire like this and your thumb, the way it is stretched along the wire, if the current, sorry, is flowing from the bottom, following the thumb, I can see the arrow there directing the flow of the current. If the current is flowing from down or the bottom to the top, you can see that there is another arrow that is coiled, which shows the direction of the magnetic field. So if this happens this way, then the magnetic field will go this direction, which is in an anti-clockwise direction. But if peradventure there's a turn and then the current is flowing from top to the bottom, then the direction of the magnetic field will be in a clockwise direction, just like in the other way around. All right, let's talk about the Earth's magnetic field. The Earth's magnetic field is due to a belief of an imaginary bar magnet situated at the center of the Earth and inclined at a small angle to the Earth's axis of rotation. This bar magnet has its south pole at the Earth's geographical north and its north pole at the Earth's geographical south pole. This is confirmed when a suspended bar magnet comes to rest with its axis pointing roughly in a north-south direction. The magnetic element of a place. All right, before we go to the last paragraph, this is talking about the Earth's magnetic field. This is telling us that there is an imaginary bar magnet situated at the center of the Earth, which is inclined at a small angle to the Earth's axis of rotation. The reason why we agree to this is because of the practical that can be done in the lab. When a bar magnet is kept horizontal, the bar magnet is suspended, but it is tilting a bit, leaving itself settling or resting at a north-south direction. This shows that there is another magnet that is situated in the geographical plane of the Earth that is dragging the north pole of the magnet to the north geographical pole. You know, we have the north, east, west, and south. We are talking about that the Earth's bar magnet, which is imaginary that we cannot see, is located at the center of the Earth, and the south pole of that magnet is located at the north geographical setting of the Earth's geographical setting. So that is that. The magnetic elements of a place are the angle of the dip, angle of declination, the horizontal component of the Earth's magnetic field in that place. All these affect the behavior of a bar magnet in the Earth's magnetic field. All right, we come to the end of our class. Conclusively, we can see that we have run through some things. I want to just take a recap of what we have gone through. I told you that a magnet possesses a force called magnetic force, and this force is felt around the magnet in a region known as the magnetic field. The magnetic force of a magnet flows from the north into the south pole of a bar magnet, just like we had in the diagram that was shown in the previous slide. The right-hand rule is used to trace the magnetic force of a current carrying conductor, which we already shown using the right-hand rule. The Earth also has a field due to the imaginary bar magnet at the center of the Earth. This Earth in the behavior of bar magnet existing in the earth. All right, thank you for listening. And this is a project work that the students have to engage themselves with as they stay for some days at home. The number one is, with the head of a drawing paper or cardboard paper, draw the magnetic field pattern of one, A bar magnet, B unlike poles, and then C like poles. I think I made the one of the bar magnets as we saw in the slide, and then the remaining two, they can incorporate that in their work. The second question is, make drawings of a magnetic field pattern in the Earth's magnetic field, showing the neutral point of the A north pole pointing north, the south pole pointing north. Then lastly, write briefly on the two ways of making a magnet. I believe you find this simple, even as you research and get more knowledge on the topic, the magnetic field. Thank you, and God bless you. See you as you return. Thank you very much. I still remain your teacher, Mr. Nwogu Eric. Thank you.